Hello, welcome to my kitchen. Why are we in my kitchen? Well, apparently there's a global pandemic going on. Oh, no, why in my kitchen? I don't own a whiteboard, but I do have a refrigerator and I can write on my refrigerator, so that's what we're going to do. Alright, so I know before we left I said we were going on to fossils after volcanoes. Changing plans. We're going to hold fossils off until we're actually back together again so I can actually show you stuff in person. So we're moving on to weathery things. I was going to film this outside, but it's kind of rainy outside. I don't feel like filming in the rain, so we get to do this in the comfort of my own home. So, we're going to start with atmosphere. What is an atmosphere? That's where you were supposed to be answering. I know it doesn't really work that way on video. So, atmosphere is the thin layer of air surrounding a planet. Why do we have an atmosphere? Or what does the atmosphere do for us? Well, atmospheres do several things. First, it protects us. Any ideas what would happen if we didn't have an atmosphere? Well, if we didn't have an atmosphere, daytimes would be crazy hot. We'd be full brunt of the sun's energy. Temperatures would be really hot, really hot. But then at night, when the sun goes away, it would get really cold. See, our atmosphere holds in heat, but it also holds out heat. It's kind of like insulation. Also protects us from the UV rays and other radiation that the sun puts out. So it is an insulating blanket. It also protects us from harmful radiation and regulates our temperature. So what is our atmosphere made up of? If you were to guess, and that's what you're going to have to do here in a minute, what is the most common gas in our atmosphere? What makes up most of our atmosphere? Right, so I'm going to guess that most of you probably said oxygen, because that's why we breathe. We have to breathe oxygen. And you are right, there is a fair amount of oxygen in our atmosphere, but probably not as much as you think. One or two of you might know the real answer. There are some other things in our atmosphere. Nitrogen. N2 is nitrogen, if you were wondering. There are other things. There's water vapor. And then all kinds of other things. There's a little bit of carbon dioxide and some carbon monoxide. I don't know why I wrote the one. Some argon, some other things in there. There's also some solid things. Dust, dirt, smog, pollution, whatnot. But most of our atmosphere are those two things there. In fact, almost 99% of our atmosphere are made up of these two things. The surprising thing is about 78% of our atmosphere is nitrogen. And then about 21% oxygen, and then the other 1% are all these other things. Alright, so I had to take a break to clean off my whiteboard. So where were we? Oh yeah, atmosphere. We need to talk about chocolate milk. What does chocolate milk have to do with atmospheres? Good question. If you took a cup of chocolate milk, sorry, I'm been distracted by my window. If you took a cup of chocolate milk, set it out on a table, and just left it there, what do you think would happen to it? Besides, start to spoil. Ignore that part. Pretend it doesn't spoil. Alright, so after time, you would probably find that your chocolate milk had a layer of thick, goopy stuff at the bottom, and then some other stuff, and probably a top layer of mostly water. Why? What do you think would cause that to happen? All right, so if any of you said gravity, good job. If no one said gravity, you should have. Gravity pulls heavier things down to the bottom. Remember when we talked about why magma wants to get to the top, because it's less dense than the rock and wants to get to the top. Same thing here. The more dense stuff, so the chocolate particles and things like that, are going to get pulled to the bottom, and less dense stuff above that, and even lesser dense stuff above that. Same thing happens with our atmosphere. The reason we're stuck down here on the bottom of the atmosphere, we're more dense than everything else, so we're stuck here at the Earth. But oxygen, gases are also affected by gravity. And because of that, our atmosphere has layers. The bottom layer, I guess I should write down here, is called the troposphere. Troposphere is the layer that we are in. When you go outside, you are in the troposphere. And it extends up to about 10 kilometers, which is 6-ish miles. 99% of the water vapor and 75% of the gases in our atmosphere are within those first 6-ish miles of the troposphere. All of you have lived your entire existence in the troposphere, and will until you figure out how to go to space. If you've been in an airplane, you're near the top of the troposphere, but you're still within the troposphere. All right, above that is the stratosphere, and it extends from that 10 kilometers up to about 50 kilometers, which is 30-ish miles. Part of the stratosphere is also known as the ozone layer. We'll talk about ozone layer at some other point. Above that is the mesosphere. The mesosphere extends up to about 85 kilometers. Math. So that's another 30. So another 3 of those. So 50 miles. Above that is the thermosphere, which extends up to about 500 kilometers. This is kind of the biggest, which is 300 miles. This is kind of the thickest layer of our atmosphere, with the possible exception of the last one is the exosphere, and that's everything above 500 kilometers until the atmosphere just stops. Recently, scientists discovered that the moon is technically within our atmosphere still. There are still particles of atmosphere around the moon. They're extremely far, really far spread out, so it's kind of just a technicality. So that goes, 230,000 miles away. So technically, why do I keep leaving the E's off of spheres? So technically that's the thickest, but this 85 to 500 kilometer thickness, the thermosphere, is the thickest of those. All right, you're gonna have to pause to clean board again. All right, so I'm back. Another word we need to learn. Well, you already know the word. Pressure. What is pressure? Have your ears ever popped? All right. When does that happen? Probably happened as you went higher up. If you ever driven up a mountain, flown in an airplane, whatever, you've experienced your ears popping. And you've also probably experienced the opposite of that when you've been swimming. If you go deep underwater, your ears start to hurt. All of that's due to changes in pressure outside of your head. As you get higher above the planet, the amount of air pressure gets less and less. As you go underwater, the pressure gets higher. My question is, why? Why is there more air pressure closer to the planet, less as you go higher up in the air? To answer that question, we need to talk about football. Imagine you are running with a football and you get tackled. And you don't get tackled by one person, you get tackled by 8. And they're stacked up on top of you. So you on the ground, 8 people piled up on top of you. How much weight is on you? I'll wait for you to do the math. Right, there's 8 people. So what if you were the first guy that tackled the person instead of the person that got tackled? How many people are on you? 7. Good enough. All right, what if you were the middle guy? So you're the 4th person. How many people are on you? 4, well, 3 if you're the 4th person. What if you were the last guy? How many people are on top of you? None. So which one is experiencing more force? All right, so the guy that got tackled has 8 people on top of him. So there's a lot of weight on him. The next guy, there's 7 on top of him. So there's still a lot of force, but not quite as much. The guy in the middle, there's only 3 on top of him. And the guy on top, there's only 1 on top. There's nobody on top of him, so there's no pressure. The same thing happens with air. You've got the earth down here. And you've got, remember, atmosphere goes out to, well, 200,000 miles, but most of it's in the first 10. So this bottom layer has got all of this air pushing down on it, so there's a lot of pressure here. This layer up here, there's only this much, not as much pressure. Up here, even less. So this is the guy on the bottom, all of these people on top, lots of air pressure. As you go higher up, there's less air on top, so less pressure. And we don't think about gases being affected by gravity, but they are. All right, so now you need to actually do real work. Well, no, the stuff on the computer is real work too, but you get to do stuff in your book. Now, there's not a way to turn this stuff in. We're going to arrange turn-in days probably sometime next week. So any written work that I assign you, you need to turn in, hold on to, and turn in when we have turn-in days. So in your books, you need to do page 433, questions 2 through 4. It's only 3 questions. Shouldn't take you very long at all. I miss seeing you every day. Hopefully the end of the world will end soon and we'll get to go back to school and do this the right way.